Basically, through this, we can now see what sine and cosine of 45 degrees are, right? You have a right triangle that has an angle of 45 degrees, and we know all the side lengths. So now we can get all the trig functions at 45 degrees, and that's what I'm doing here. Now, you can't just form your triangles arbitrarily, so to say. With specific angles, you have to figure out what the side lengths could be. But anyway, basically what we get when the dust settles is that you get this right triangle, and so sine and cosine of 45 degrees, right, we can get, namely sine of 45 degrees is opposite over hypotenuse, which is 1 over radical 2. And what I did over here was I rationalized it. Remember, I think we did that. I did mention that earlier. Pretty confident I did that with you guys. What I did was I took out the square root from the denominator by multiplying and dividing, by multiplying top and bottom by square root of 2. And you get square root of 2 over 2. All I did was I rationalized this. I did go over how to do that earlier. But notice also that cosine of 45 degrees is also 1 over radical 2. And you get tangent also as opposite over adjacent, which is 1. You can also see it from the, from this trig identity. Tangent of any angle is sine over cosine of that angle. These are equal, so tangent has to be 1. And remember, we talked about radians. I just converted 45 degrees to radians, although we have seen that as well. That's pi over 4. So we have all these trig functions now. These 3, that is. We have all these 3. Let me just check my notes for a second. Oh, okay. I didn't write down what secant, cosecant, and cotangent are. You should be able to see what they are, though. Basically for secant and cosecant, they're actually going to be the same because sine and cosine are, and that's just going to be 2 over radical 2. And cotangent's also 1 because that's 1 over tangent. So all I did here again was I wrote the angle in radians as well. So once you know these 3, you can easily get the other 3 trig functions. So really, as I have up here, once you know sine and cosine, you can get tangent. Now that's for 45 degrees. I'm not going to ask you to prove that sine of 45 degrees is actually equal to this number on a test or something. I wouldn't do that. So I'm just showing you why this equation holds and why this equation holds. Again, it just comes from considering special kinds of triangles. That's all. Now we can also consider what's called an equilateral triangle. Remember, that's a triangle where all 3 sides are equal. So in this case, I'm saying, well, let's say they're all equal to 2 in length. That's actually just there for convenience, the 2. If I change this number from 2 to something else, say, I don't know, 1 or even 10, you'll actually see if you go through the calculation that the value of the trig functions will be the same. But from here, what I can do is I can draw what's called, basically I get the perpendicular bisector. That's really what I'm saying here. And by doing that, we end up forming 2 congruent triangles. Basically, we get these 2 triangles are congruent, so they're essentially the same. This triangle has length 1, this has length 2. This angle up here is actually 30 degrees. Also, since all the sides are the same, all the angles are the same. Well, if they're all the same and the sum is 180 degrees, that forces the angles to be 60 degrees. So basically what I get is, I get this kind of right triangle. We have this kind of right triangle is what I'm saying. we have what they call, I think it's called a 30, 60, 90 right triangle. The hypotenuse we got is 2, right? So you could think of it as this triangle we're using, although it really doesn't matter because they're congruent. This side length is 1. Since it's a perpendicular bisector, it's cutting this side in half. So these two sides are both equal. But what's the height, though? Well, for the height, again, Pythagorean's theorem. I'm calling the height h, and I'm just calling it, and by Pythagorean's theorem, the height is the square root of 3. And then from here, again, we get sine, cosine, and tangent. So once we know what sine and cosine are, we actually can get all the trig functions. So I have sine, cosine, and tangent here. As you can see, right? We have our right triangle. Sine of 30 degrees, right? Here, it's relative to this angle, 30 degrees. You want to find opposite the angle divided by the hypotenuse. So sine of 30 degrees is opposite 1 over hypotenuse 2. 30 degrees is also pi over 6 in radians. Again, to figure out sine of 30 degrees, you take opposite over hypotenuse. But remember, opposite is opposite relative to the angle. I mean, what we've been doing is opposite relative to the angle that was here. So theta I would put here, remember? Now the angle's here. It's really the same idea though. Opposite over hypotenuse. Cosine of 30 degrees is adjacent over